question number 3 was about the flask. Pretty straightforward question, but a few people threw marks away by ticking more than one box, ticking all 3 boxes, or not ticking any boxes. Complete the table. So the silvered surface is very simply just radiation. The plastic cap is convection, but it's also conduction. If you put the ticks anywhere else, you lost the marks. Explain why the vacuum between the glass walls of the flask reduces heat transfer by conduction and convection. Well, there's no particles to transfer the heat, so conduction needs particles, no conduction. Convection needs particles, no convection. Most people got this page completely correct, which is good, because this bit is a little bit foundation, and you guys are better. 1B. Explain why the top surface of the reflecting hood, there's the key, the reflecting hood, should be a light surrounding surface rather than a dark matte surface. Well, it's to reflect the heat away. It's a patio heater, so you need to get the heat away from the patio heater to heat the patio. If you had a dark matte surface, it would absorb the heat, and therefore less would be given out to the surroundings. 2 marks. You need to say why it's shiny, why it shouldn't be matte. Again, most people got this, but they didn't always get the second mark because they didn't put the reason why dark matte shouldn't be used. 1B2. Most of the chemical energy in the gas is transformed into heat. A small is transformed into light. Draw and label a Sankey diagram for the patio heater. Well, it's chemical energy coming in. Mostly gets transferred to heat, and a little bit gets transferred to light. Don't worry about the relative proportions. If you knew what a Sankey diagram was, you got this right. If you didn't, don't worry, we are going to revisit this in future lessons. B3. State why the total energy supplied to the patio heater must always be equal to the total energy transferred by the patio heater. It's because energy can never be created or destroyed. The law of conservation of energy. Okay, this is the follow-on question, which is about the heater. You've got 3 different heaters there. The first one talks about the ceramic heater run on full power for 3 hours. So on full power, the ceramic heater is 1,800 watts, but it does tell you to use kilowatt hours. So the power is 1,800 watts, which is 1.8 kilowatts. The time is 5 hours, which is 5 hours. So 1.8 times 5 is 9. Lots of people put 9,000 because they'd forgotten to convert 1,800 watts into kilowatt hours. That's fine. We'll be going over this in the lessons in the future. 2B, which will be the most expensive to run on its highest heat setting? Well, it's the one that has the biggest power, which is the fan heater. And the last bit, a heater is needed for a small office. Comparing each type of heater with the other two, give one advantage of using each type of heater in the office. Well, you couldn't just list anything that was written under the heater. But as long as for the first one you didn't say it had a cutout, as long as for the second one you didn't say it had a power indicator, as long as for the third one you didn't say it had a power indicator or a cutout, anything else you could have said in the lists would have worked. And of course, if you'd have said got a cutout for the oil-filled panel heater and you'd have got it wrong. If you'd said power indicator for the fan heater, you'd have got it wrong because it's not an advantage that it's got over the other two. Again, pretty well done question this here. Again, like the second one, a pretty just about, but pretty solid higher tier question because you're having to extract information from text and you are being presented with heaters that unless you are a heating fan, you won't have much experience of.